Good morning, everybody. I'm Sébastien Lahaye from Pau Costa Foundation, working also in France. It's a pleasure for me. I'm very honored to moderate this first session 0 on global wildfire challenges. We have a very, very good and very experienced panel there. You will discover that during this first hour. So I won't say more. I will just introduce the first speaker, who is Marc Castellnou. But do I need to introduce Marc? I'm not sure. I'm quite sure everybody knows Marc, but anyway, that's my job today. So Marc created the graph unit a couple of years ago now, and has been at the head of this unit for now. And Marc also, regarding this being implied in so many projects, it definitely is on the way to change the way we consider wildfire response, but also land management in Southern Europe and Western Europe. So it is kind of an inspiration for us. Marc will do the first presentation on the fires in state of the art or update on fires in Catalonia.
Well, good morning. I will go start the presentation because we need to do a lot of things today. That's a picture of a fire. We'll let it burn on the Pyrenees. It's not what normally we do in Europe, but it's part of the job we are already doing. We know fire behavior. We know what fire will do. We have a lot more data about forecasts, so we feel confident to start letting fires play their ecological role. We will talk about prescribed burning a lot today, and we'll see tomorrow. But one of the important things we get out of you as operational people, we get out of you as a research people, that burning in wintertime is changing our ecosystem. So if we want to apply fire ecology, we must burn on summertime when our forests are used to burn. So that's something we learned in the last 20 years and something we're already applying in Europe. But most important issue for us is that kind of thing that are extreme wildfire events. That's Portugal. Last year, we will talk about these a lot next year in Coimbra, but that's a nice picture of, or a terrific picture of what we are having in Europe. Those incredible wildfire behaviors in the middle of all our historical towns and our population. We are a densely populated continent, and now we are having just incredible wildfire problems. So we are going from the forest fire to a civil protection problem. We are facing unknown fires. All our prevention we've been doing needs to be redefined, and climate change is driving part of the problem. But that's who we are. We are firefighters, and we are confronting things that you haven't explained to us still. I mean, for the first time, maybe since I am in the fire business, I've been my 32 seasons in wildfire already. For the first time, we operational people, we see things, we explain things, you research people don't explain to us. So that's a challenge. You must speed up what you are doing. We need it because we see things, we don't know how to explain them. So that's the classical explanation. So the more full load we have, the more intensity our wildfires have. That's the Australian case Albever did in the Black Saturday 2009. And those are the limits of our fire capacity. So more than 10,000 kilowatts per meter, we cannot fight them. And so fires can show a lot of energy. 90,000 that moment, more than 150,000 in Portugal last year. So we are overwhelmed. That's the case of one of the fires in Portugal, but this is a slightly different thing. You see, the moment we got, allí no, en pantalla no. Well, the moment you see the peak of the intensity, it's close to the evening, not at the peak that was forecasted. One thing is what was forecasted by the meteorological conditions, and the other thing is what really happened. That's totally different than Black Saturday, when situation the worst energy happened at the moment it was predicted it will happen because of the meteorological condition. So there is, in this new case, there is not a coincidence between the conditions about the fire models we know and what really happened. And that has been agreed. All the fire models we use, they are not working anymore in those types of fires. We need new fire models. Because those are the new fires we have. Compare the big Thomas fire in the United States last year, 20,000 hectares per day at its highest peak. But compare Chile or compare Portugal, 100,000 hectares per day. And that's not a joke. That was happened. We went to bed with one fire and we wake up with a fire of more than 114,000 hectares the next morning, and it was amazing, unbelievable. And we thought, well, that has been a mistake or some strange things. But then it happened in Portugal twice, in June and October. So we are facing problems that our models cannot explain. So as an incident commander, I am sending my kids, I am sending my people to fight fires. We cannot predict, we cannot understand, we cannot know in advance. They are rare, but they happen. And they're happening in Europe, where we have thousands of people living inside those forests. And we thought that will be a Mediterranean thing. But last summer, we had the first pan-European fire season. And 23rd of July, we have fires from Norway to Greece and from Portugal to Ukraine. So it was a global season in Europe like we've never seen before. That's climate change. And those fires has a strong power of changing things. That's an example of 15 October in Portugal. That's the windmills, speed of the wind, speed of the windmills, 500 kilometers surrounding Portugal fire. And the peak of the wind at 16 hours, it's caused by Ophelia hurricane or a strong tropical storm hitting Portugal. It was the first time in 20 years, this time did it again. But what you see at midnight is the collapse of the pyrocumulonimbus over Portugal that created even stronger winds than Ophelia storm. And those winds fell 500 kilometers away from that fire. So those forest fires we see are changing a lot of the knowledge. And that's, I hate to show this picture, but it's a really good picture. Look at this picture, which is the most intense fire we can see our models predict, crown fires. Look at the crowns there. They got the needles in it. It was not a crown fire. If you apply surface fires, it's unpredictable. If you're a crown fire, you are falling still behind the model. Just to play ground fires, you have to adjust by a factor of adjustment of 3. But for those forests, you have to adjust by a factor of 6 at least. So it doubles the knowledge we used to have. And look at that. That's the data of that fire at noon. Temperature more than 40 degrees, humidity below 20%. Well, that's really extreme, but those things happen at 8 in the afternoon when temperature was below 30 and humidity was above almost 40. So when situation should be improving, it was getting worse. And that's because all the transition, we know how to explain it, but we cannot predict it. That's the important thing. We still cannot predict it, and not any industry can explain that for us. And that's a comparison of 2 fires that day. I'm using power of the fire, power of the wind, so the Rothermel's data to predict those pyroconvection wildfires. And the first graphic, the orange line and the gray line, they are the intensity of those fires. The orange one is the predicted by the model. The gray one is the one we observed on the fire. And the same in the other side. But you see when humidity is going up, conditions must improve, is when the initial fire starts to go down like expected, like predicted. It was a normal fire. But the other one, as soon as humidity started to go up, it created the big peak up to 80,000 kilowatts per meter. And that's the transition to pyrocumulonimbus and its collapse. It's all different type of fire. And that's surprising fire behavior is what's killing people. The last 2 years in Europe, fires has killed a lot more people than the all terrorist attacks together. But they haven't got as much attention of it. But that's true. Fires are, in Europe, which is populated, are killing more than any other natural disasters. el vídeo el podeu clicar a dintre. Clica, a veure si funciona. Clica aquí, la imatge, sí. That's the process of creating in Cheste, in Valencia, Lucent, last year of one of the pyrocumulus. It didn't make the transition to pyrocumulonimbus, but you will see now the white mark of, you see the storm coming, and now you see the white pixel, that's the fire, and the big storm coming, and now you see the big mushroom appearing. That's pyrocumulonimbus in Europe. We come from Chile, and we thought, well, strange things. We must prepare in Europe. 6 months later, it happened in Portugal. And we said, well, it has been a strange year. Well, 9 months later, after the last pyrocumulonimbus in Portugal, it happens in Valencia. So it's getting close to here, and we are not prepared. We are not prepared. We have a limit of 10,000 kilowatts per meter when we fight fires, and those fires show more than 100 kilowatts per meter intensities. And that's Greece. I have to discuss, we discuss a lot with some friends here in the room about Greece, but we developed a tool of convection with our satellites, Meteosat satellites, the new generation of satellites, looking for vertical velocity of our winds. And as you see in that picture, and in those two pictures, you see the yellow one, which is the lee wind effects in some mountains, but in that one, you see over the coast at the right, a yellow point, which is not marked in this picture, which is 5 minutes before. So what we really see there is the pyroconvection. At the moment that the power of the fire overwhelmed the power of the strong winds in those fires in Greece. And again, a similar process than in Portugal, 15th of October. Unpredictable, unexpected. 5 months later, after the fire and 90 people dead, we are still discussing if that's possible or not. So Mr. Caballero and I will discuss strongly about, is that possible? That's not possible. It was a wind-driven fire. Oh, no, it was a convective fire. How on the earth you want, we, operationals, take decisions about those fires in minutes when you research people take months to agree on what really happened? How on the earth you are asking us responsibilities for that? So we ask you to come here together because we need answers. I will be sending my kids tomorrow to those fires, and they will be unsafe, totally. So we must understand. That's comparing some fires. I compare Black Saturday 2009 with Pedro Grau Grande in 2017. Look at that. They are the same type of fire, and they do the same jump. The only difference is that Black Saturday jump at 16 to 17 hours from almost 9 kilometers an hour to 21 kilometers an hour. It was, wow, impressive fire. But then it comes Pedro Grau. It jumps up to 15 kilometers an hour, just during half an hour. And then there we compare the fires in Winter Hill in England. As you see, they got fire behavior above the capacity they have to fight fires, and above the capacity we have to fight fires. It's not that the Northern Europe is getting fires they don't know how to fight. It's that Northern Europe is already getting fires that we don't know how to fight even. And that's another example of the fire we will see tomorrow. And that's a comparison about what is predicted, which is in green, and what was observed, which is in yellow, in red. So we are just really far away from what we can see. So full management is what we have to be doing, but there is a limit. And after this limit, fires are changing a lot. Fire is a need in our landscape because it plays an ecological role. And we've been avoiding it, and that's driving the momentum. So that avoiding of the fire, that abandonment of the rural societies, and the climate change are driving a moment that are creating a new type of fires. We don't know how to fight, but the worst of it, we don't know how to predict. We know how to explain months later, but not at the moment where we have to decide. So for the first time, we operationals, we see things, we do things ahead of what you explained to us. And that needs to change. And that's why we are here today. Thank you.